Okay, today I want to talk about the sum and product of polynomial roots. We've talked a little bit about, well, quite a bit about polynomials and the roots of polynomials and the fundamental theorem of algebra, which states that for an nth degree polynomial, we've got to have n roots, some of which may be real, some may be imaginary. Combination of the two, imaginary or complex roots, come in pairs. Okay, so now we're looking at the sum and product of polynomial roots. So not the actual roots themselves. We're not necessarily in this section. We're not so concerned with what the roots are. It's the relationship between the sum and product. So let's have a look at familiar territory. This is what we like to do, isn't it? We look at what we already know and we draw on that knowledge and we take that forward. So so let's have a look firstly at a quadratic polynomial. Okay, and with a quadratic polynomial, we know that we've got an ax squared plus bx plus c. And what we do, there's our general quadratic, and in order to factorize it, find its roots, we understand that there might be this a comes out the front, and then I know that I've got two roots here, and we're going to call them x1 and x2. Okay, so this is the first thing to understand, is that we're saying that x1, x2 are the two roots of the polynomial, the two roots. x1, x2 are the two roots. All right, when we move into a cubic, there'll be x1, x2, x3. So we're looking at those roots, and we're going to explore what happens with the sum and product. Okay, so the way to proceed here and to establish what the relationship is between the sum and product of the roots and the coefficients of my polynomial is to look at expanding expanding this. So this is in factored form. I don't know what x1 and x2 are, but it factorizes to something, and this is just its original template form. Okay, so what I want to do is match off the coefficients. So the first thing I'm going to do is divide both sides by a. So I end up over this side with x squared plus b over a x plus c over a, and on the right hand side just my pure x minus x1, x minus x2. Okay, now I'm going to hold this for a bit because that's fine. But what I want to see is I want to expand this and then match off against this side. So on the right hand side, I'm going to have here x squared minus x2x minus x1x. Remember x2, x1, they're little underscores, plus x1, x2. Okay, so on the right hand side now I've got x squared. Now I want to work out what my, actually it's going to be a minus there, isn't it? What my x coefficient is. I'll find it's x plus x1 plus x2, x plus x1, x2. Let's have a look at this. On the left hand side I've got x squared plus b over a x plus c over a. And in factored form, this is what it looks like. So therefore, we're going to say, therefore, look at this. I've got my coefficient of x here is minus x1 plus x2. My coefficient of x here is b over a. So therefore, minus the sum of x has to equal b over a, or the straight sum will be equal to minus b over a. Okay, and we can also see that the product here, x1, x2, is equal to c over a. x1, x2 is equal to c over a. So there, actually I'll just bring that down to this level here. x1, x2 is equal to c over a. So we've got this result here where my sum is equal to minus b over a and our product c over a. So for a, for example, if we had a polynomial, find the sum and product of the roots of 3x squared minus 2x plus 1 equals 0. We would say, therefore, sum is equal to, it's a quadratic, sum's minus b over a minus b over a. So I just go to my a's there, b's here, and c's here, minus b over a, that's minus 2 over 3. So it's just 2/3. And the product of the roots, whatever they are, is equal to c over a, which is 1 over 3. C over a, which is 1 over 3. And there we're done. So sum and product worked out in such a way. Okay, let's move into quartics. So let's have a look at, so not quartics, cubics. So for a cubic polynomial, let's have a look at what goes on here. There's a little bit more expanding to be done, but so I'm going to start way over here. But I'm going to start with my ax cubed plus bx squared plus cx plus d. That's my cubic polynomial, and I'm going to have a look at it in factored form, where my roots are x1, x2, and x3. So as we did above, we're going to divide both sides by a. So therefore, and I might just switch sides. So therefore, my factored x1, x2, x3 form will be equal to x cubed plus b over a x squared plus c over a x. We're just dividing every term through by a plus d over a. Now my job is to expand the left-hand side here, which in order to do so, expand these two, x squared minus x2x minus x1x plus x1 x2. That's that there. I've got to now bring in my x minus x3. So really what I'm just doing here is just working with my left-hand side, which now equals x cubed, once I do that, minus x3x squared minus x2x squared plus x2x3x minus, I'm now in here, minus x1x squared plus x1x3x. Easy to lose track. I'm now up to here, I think. So plus x1x2x minus x1x2x3. Right, so now let's get this sorted out into x cubes. Now x squareds are all minus, I think, so I'll put a minus here, and it will be x squared. Here's an x squared term, that's x3. There's one x1, and there's one x2. So it's the sum of x1, x2, and x3, x squared. If you have a look at that, this is the factored form of the x squared terms. Now I want to group my x's. So how many x's do I have? Now I have a look down here. I've got x2, x3x, x1, x3x, and x1, x2x. So there, x1, x2 plus x1, x3 plus x2, x3, lots of x. And finally, it's minus x1, x2, x3. So we can see now that my sum, x1 plus x2 plus x3, the minus of it is equal to b over a. So again, my sum, x1 plus x2 plus x3, will be equal to minus b over a. So that the sum of a cubic, same as the sum of a quadratic, and we can take that as read, that the sum of the roots of any degree polynomial will be minus b over a. Okay, and from there we've got it's not just product, we've got products two at a time here. So my product of x1, x2, get that right, x1, x2 plus x1, x3. So it's the combination of the products two at a time. x1, x2 is equal to, what are we saying? That's equal to c over a Notice how the sign alternates there. We'll just pick up patterns. And finally, the product, x1, x2, x3, minus d over a, minus d over a. So what we have is the sum is always minus b over a. That is something to pull out. So the sum always equals minus b over a. And b is the second coefficient in, the leading coefficient being the a, the second coefficient in. So the second coefficient in is b. The sum's always minus b over a. Now, in this case, always our last d is always going to be our product. Now our product is equal to, let's have a look here. It was minus d over a here. Now d is our constant, so it's going to be the constant over a, but it's just a matter of whether it's positive or negative. The constant here was c, so the product was c over a positive. The constant in a cubic is d, and our product is minus d over a. So we can say therefore that if it's an odd polynomial, it will be minus. So it'll be we can say minus 1 to the n, can we? Does that say that if n's odd, this will be negative? Minus 1 to the n, the constant times the constant term over a, if that makes sense. So it's the minus 1 to the n, which means that if n's even, it'll be positive. If n's odd, it'll be negative. The constant term in the polynomial, so the last term in the cubic d, over a. In the middle here, we're going to have for anything a cubic or more, we're going to have a product 2 at a time, or 3 at a time, or 4 at a time. We just pick up more and more. So all the letters in between the b and the constant are going to be picked up by coefficients 2, 3 at a time. So if we look at a quartic, we would look at products 2 at a time, but then we'd also have products 3 at a time, and then we'd have a c over a, d over a, and an e over a down here. So that's how the pattern works. Really what we need to do now is just do some questions from exercise 3n, get a little bit of practice, which is what we'll do when we meet in class next lesson. I'll see you then.